This is the Amp Hour Podcast, recorded previously but aired on May 13th, 2012. Episode 95, with guest Oyvind Janbu, Feracious, Fabless, Facilitator.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chris Gamble's Analog Life.
And I'm Oyvind Janbu. I'm CTO at Energy Micro. It's great to be here.
Thanks for joining us. Oyvind,
Yeah.
if I'm pronouncing your name correctly, it's very difficult for us Australians to pronounce that. I'm sorry.
Yeah, I know. But it's good. It's good.
It's a very common first name, isn't it?
Actually, it's a very common first name in Energy Micro, but it's not that common in Norway.
Oh,
But,
okay, right.
We have a high percentage of Oyvinds in the company, which is, I think, a fantastic advantage that we have.
Right. So if you're going for a job at Energy Micro, it's
Yeah.
if you got the correct first name, I think you're a shoo-in.
Yeah, actually, it's also possible to change your name if you really want the job.
All right, that's good to know.
If you're really serious. and
People the
you're-
world round. If your name's Mike or Bob or anything else, they want you as Oyvind.
So you're the Chief Technology Officer of Energy
Yes.
Micro, which is a startup.
It is.
What does a CTO actually do?
So what do I actually do, or what am I supposed to be doing?
Right, both.
Okay. Well, if we take the last question first, what I'm supposed to be doing, I'm supposed to be basically defining our roadmap and figuring out what to do next and what to do for the future.
Right.
And then there's another guy responsible for actually doing it.
Right.
So we can give you suggestions today. We want this chip, we want that chip, and then 16 to 18 months from now, we'll see it on the shelf.
That's how it works.
All right.
Fantastic. All right.
Only CTOs on the show from now on, Dave. We can start
sounds
steering the
good to
whole
me.
industry like
And
this.
we love having
Yes.
CTOs on because it really gives us a technical insight into companies like this, which we only ever see from like the outside and from the chips and the salespeople and things like that. So it's really good to get an insight. So
I think
do you
CTOs
actually...
are really interesting too because it's like an executive level position, right? And yet you're still, your hands are in the technology. You're still, actively, what's going on versus sometimes that stereotype of executives who are more looking at the numbers and dealing with the high level stuff versus the
real stuff.
gritty nitty, the awesome stuff, right? The stuff we care about here.
Yeah, exactly.
So do you still get your hands dirty on a daily basis?
I do. I mean, sometimes I do what I'm basically supposed to be doing.
Right.
Other periods, I do work hands-on on our chip development or specific tasks. So, I mean, we're still a small company, right? And so people internally, we do what we need to do to get the chips out and get the software out, and
So it's
make
more
our
of a
customers
case.
happy.
It's more of a case if you do it because you have to, because you don't have hundreds of employees to do all the work. So it's all hands on deck.
Yeah, I think it's partly kind of do it when you have to, and partly, of course, because I'm still
You're still a
the
tech.
kind of hacky engineer, and I mean, what I enjoy the most is to actually sit down and make stuff, right?
Awesome.
Excellent. That's brilliant. We love this guy already.
We need every executive to be like that. I'm not hopeful for every executive, but that's amazing that you are. And there's another
Thanks.
example of that too, like Bob Dobkin from LT. I know that he's a CTO as well. I was talking about him the other day, and he's still making chips as well. And
he's still
that's
making
just-
videos as well. He did a recent video for the LT 3080 as well,
Nice.
explaining how it works. I mean, wow.
Yeah. So you guys are a rare breed, and it's really cool. it's really cool, man.
Yeah.
I aspire to that someday. Yeah. So
We've got a whole bunch of viewer questions, and I don't think we'll get through them all. So apologies to people who submitted questions and we don't get to them. Maybe we'll get to them in a roundabout way. But there's one question on here which raised a point right now from Hacked Fridge Magnet. That's his username from our forum, and he says basically discovered that both you and your CEO are graduates from the same university. Is that correct?
Yeah, actually, I think, I don't know, like half or 2/3 or more probably of our, say, engineer employees are coming from this university. Because it's basically the best and biggest technical university in Norway.
Got it. How many universities in Norway? Because you're not a terribly big country, are you, in terms of population and...
No, actually, I mean, I would say universities with education relevant to engineering, kind of software, hardware design, probably 3. But we also have other universities, I mean, smaller ones that are coming.
Got it. And are the majority of your employees from Norway, or all of them?
Yeah, well, the majority is from Norway, yeah, for sure. But we're quite an international company still. We have, I think, 5 or 6 Chinese guys employed in China.
Okay.
I mean, working with sales and FAEs and app reference designs and so forth. And similar also smaller groups around the world, both in sales and support.
Right.
And operations. And so we're quite an international company. Also in the design team here in Oslo, in the chip design, we have people coming from Korea and Canada and Netherlands. And I think a guy just employed now from... I probably don't even remember the right country. Anyway,
it's almost necessary these days. That's talent comes from all over, right? And
it does.
The fact that you guys are pulling in talent from everywhere, that's a good sign of a company. You know, the fact that you're recognizing that there's good talent everywhere. So that's awesome.
Yeah.
And Hacked Fridge Max's actual question, what he was getting at, was that how important do you think it is that a CEO of a company like this actually has a technical background, is actually an engineer in this? Do you think that's important, or is it better to have a CEO who's just interested in the finances or something like that?
I think it's a really good question. So my experience from this is probably a bit one-sided, because I've been working at Engine Micro now for since the beginning basically in 2008, although the company was founded in 2007. And before that, also spent 8 years in Chipcon, which was acquired by Texas Instruments. But the whole time it's the same CEO. So the CEO of Engine Micro also was the CEO and founder of Chipcon. And he is a tech guy. But he's a tech guy, but... not to offend him or anything, but there's a reason why he's the CEO and not the CTO. But so his passion, I think, is more into building good companies, making a success, making great stuff, rather than the details of the technology. So he understands technology for sure, but he's not. Yeah, you understand what I mean.
Yeah. There's a certain skill set you need to be a CEO as well.
Yeah. But to answer the question, I think the setting that we have with say a very technically driven management, it works for sure. As long as there's at least a couple of guys that also care a lot about the finance and
the business side of things,
funding. Yeah, for sure. But I'm convinced that the other, having a less technically capable CEO is also a perfect solution in another case. So I'm really not sure what the answer is. I know that our setting works very well.
Yep.
And I'm very certain that the other setting also works.
Which would probably be a larger, like once you get like huge, like you're a Texas Instruments or you're someone like that. Maybe it's better to have a CEO who's just focused on the business finance side, and the technology's left to the CTO and others who are better.
True. Yeah.
Okay. Well, can we maybe could you give us a little more background of it? You mentioned the company started in 2007. What was the ramp like? I mean, how does a startup even start up in the chip industry? I guess that's kind of the base question, because I wouldn't know where to start.
No. As I mentioned, our CEO at NG Micro, which is called Geir Førre, he was also the CEO and founder of Chipcon, or one of 3 founders of Chipcon. And Chipcon was acquired by Texas Instruments in 2006. And
for about a couple $100 million, right? It was a fairly substantial amount of money.
It was a good sum of money.
Excellent.
Which basically led. I mean, I think Geir, he continued it for another year, leading that, basically leading a division of Texas Instruments. But at some point, he decided that he wanted to do something else. I mean, he was more of a small company guy than a large company guy. I mean,
right.
And I was there as well. I also left for another company again. But and I think, I mean, Texas Instruments is a great company, I have to say. But still, sometimes you feel you need to move on, right?
Sure.
Especially if you have the startup bug. It seems like people who have the startup bug just jump from startup to startup to startup because they get that rush. I've never done that myself. I don't know.
Yeah. I think, like you said, there was a fair amount of money involved in the acquisition, and I think a lot of people ask Geir, our CEO, about. So why didn't you just retire, right?
Yeah, that's right.
I think the main motivation for him is that basically he wants to prove that the first time wasn't just luck.
I got it. Yep.
That's that startup mentality too. It's just that drive, man. That's awesome. All you startup guys, you're crazy.
I know.
It's great.
So anyway, he and I started chatting again when I had left for a little while before, and he basically resigned. And he didn't know what to do. I mean,
right?
Whether he should start a new semiconductor company or something else, or whatever. But anyway, after him convincing me for a good while, I also resigned my new job and joined him. And we got a couple of other guys as well on the team, and basically said that, okay, let's do it. And really, we had set ourselves some quite high goals, but we didn't really know how to achieve them. I mean, not in any level of detail.
Yep.
We just thought that we'll find a way.
So did you actually have the idea before you quit your job? Like, did you have the idea that you'd do low power energy these low power ARM devices, or did you just go, let's do a chip startup and figured out what chips you'd do later? How did that work?
So when we did the, I think from the Chipcon days, we had a lot of experience with making radio transceivers and also some of them with embedded MCUs. And certainly when ARM started getting traction with their new Cortex M series, Cortex M3 at the time, we saw this as a perfect fit, right? And there weren't many licensees at the time that we were doing this, only a couple. And then basically we figured we had a very clear mindset for doing Cortex M3. There were some alternatives that we also considered, but I think more from a financial point, just to have an alternative rather than there was actually a real technical alternative. Also, I think the traction that Cortex M series has seen in the market lately it's given us a lot of advantages rather than, say, doing our own core or going a completely different direction.
For sure. Was ARM your first and only choice, or did you consider something else? And why did you pick ARM? Is it because you had experience in it, or because you knew it was going to be the future of cores?
I think it was both that we had a very good feeling for what they'd done. They had the exact right focus that we were trying to do as well. I mean, focusing on reducing both size, of course, and the power consumption. And it was basically a perfect fit. But we did have another alternative. We did also talk to MIPS at the time.
Okay, yep. Which microchip ended up using MIPS as their architecture for the PIC-32s. They decided not to go with ARM because everyone else was doing ARM, so they wanted to be different and chose MIPS. So whether or not that will pay off, I don't know.
Yeah. Well,
It makes you wonder if there is. I mean, like, is there an advantage to being kind of like the run with crowd, or do you try and just kind of eke out the others?
I think there's a huge advantage to run with the crowd in this case, at least.
Right.
Okay.
I think if you go with MIPS, which I I don't want to say anything bad about MIPS either, because the solution I think is technically good and everything. But what you end up these days, I think, is to basically spend most of your customer meeting convincing people why MIPS is as good as ARM, rather than saying, okay, we have ARM, okay, it's good, so let's talk about everything else.
Yeah. Makes getting those sales a lot easier, which is important for a chip startup. I mean, that would be, huge
and
deal.
If you look at the say the whole ecosystem of tools and middleware and everything, then you start to really gain a lot of advantages from choosing ARM rather than something which may be as good but not as well supported.
Got it.
Yeah, I kind of had that same experience with ARM. I was kind of all these vendors keep coming in and talking to me and saying, "Oh, we have an ARM chip now," and I'm like, "Okay, you and everybody else's brother." But the thing is, once you do switch over, you're like, "Okay, well now I can go to anyone, right?" And you can actually pick the best peripherals you need, the best power consumption in your case, right? So that's it's an interesting strategic decision, and obviously ARM has been benefiting from it. I mean, I guess my inner Dave, I guess it was like it was like, oh no, what if they shut down tomorrow and ARM's no longer available? And I'm a conspiracy theorist with that, but really that's just not. I don't think that's realistic. So,
no,
and if there is. Yeah, I mean, there's already the IP out there. So
well, it's just the IP, really. That's all it is, and you make your own chips from that. So you decided to do this startup. Where did the money come from? Did you have any money at the start? Did you throw your own money in? I know you got $13 million in venture capital funding from a firm, but how long did that take? And
if we go back again, so we basically decided to found the company and to give it a go. And I think we were about 8-9 employees at the time when basically we started really working, which was beginning of 2008.
Yep,
around January. And at that time, we had invested basically only our own money. Mm-hmm. A lot of it coming then from the acquisition
of ChipCon. Yep.
Yeah.
Of course.
And also to a big majority, it's our CEO who has the big the big money coming in.
Checkbook.
Yeah.
Yep.
Yes. So we've had a few rounds, but actually we managed without VC money for the first few years.
Excellent.
Which also of course made it possible for us to get a better pricing for the company once we did get the VCs in. So still we have gotten some VC money, which is true, from 2 different Norwegian VC companies.
Right.
But we still have a good majority of the shares sitting inside the employees.
So you sort of implied there that the longer you wait, the more you spend your own money and build up the company, the more you will get in venture capital funding later on? Is that?
Well, no, but I mean the better pricing you will get. So if they give you a certain sum of money, right, they will get a smaller share.
They'll get a smaller percentage, right? Okay,
yes, exactly.
They'll get 10% instead of 50%.
Yeah.
Right. Okay, got it.
Because you can justify that the company is actually, something that will live for a good while and will actually be able to make the products that you have on PowerPoint and.
Right.
Oh, yeah. It's not all concept drawings. It's actual drawings, right? Or in your case, it's schematics and chips,
or even real
else.
chips.
Yeah.
Mm. So you started in 2007, technically, and you were ramping up in 2008, but you didn't release your first product until 2009.
That's true.
Is that like that 18-month to 2-year development? Is that normal for developing your first chip as a chip startup?
I don't think it's normal. I would say it's actually faster than normal.
Oh, okay.
At least if you count. We did start in 2008 in January. I think in like April or May we actually got some servers and we actually got some design software.
Okay.
And basically, roughly a year later, we taped out the chip, and that involved. We did get some IP, of course, from ARM, like the Cortex, and also things like RAM and Flash is typically IP. but absolutely everything on the analog side is designed from scratch by ourselves. There's no IP. There's not even like the pads are IP, because there isn't anything that actually fits all the requirements that we've had.
Right. So how much of the chip what percentage of the chip would be the ARM core, and what percentage would be the low power peripherals and other things around it?
Oh, that's a good question. I think I don't have the numbers on top of my head, but the ARM core is a relatively small part of the chip area in total.
Okay.
Well, depending on which chip, of course, you're talking about. But but if we go back to the first chip family, I think it's I mean, if it's 10% or if it's 20, I would have.
Right, but it's fairly
I'm not
small.
sure. But anyway, it's not. There's no like 50%. I mean, things that typically dominate these chips are still memory, like flash.
Right.
Right, and
of course,
yeah. And also, of course, all the different peripherals and analog, and so yeah.
So that first day, I mean, like, so when you guys actually start to sit down and you have these, EDA tools in front of you, finally, is it just like, well, let's get making some op amps, time to make the donuts?
Yeah, it is almost. I mean, we did start, of course, getting like bullet point specifications, but I think we're less formalistic than if you move to a bigger company where everything has to go through all the formal reviews and everything. We're more like, okay, let's just do it and
let's make some cool stuff, kind of that kind of
exactly
mentality.
So less formal and but still with of course a very. I mean, quality is everything still, right? So we didn't take any shortcuts when it comes to verification and making sure stuff works.
Right,
that's good.
Making FPGA prototypes and doing what we needed to do.
Okay, so you actually did prototyping in FPGA, so you didn't go from just simulation and verification in software straight to the first actual chip.
No, I think I would be surprised if anyone doesn't make a FPGA prototype if you're going to make this kind of complexity, because I mean, for sure in a simulation environment you will be able to find a lot of bugs, you will be able to verify a lot, but you're still restricted by at least a couple of things. I mean, one is runtime, that once you get to a certain level, I mean, if you want to really stress test things, then I mean, you want to loop things forever and ever.
Yep.
And so making an FPGA that can run either really at the speed which is going to be live later on, or at least close to it, is a huge advantage when it comes to simulation.
That's only going to allow you to test your digital parts. How do you prototype your analog sections, all the low power stuff and your analog peripherals and your power shutdowns and things like that?
Yeah, so it's kind of challenging, but some of it we actually also have prototyped in the FPGA. Others, then we rely on the simulation environment to verify those.
Right, okay.
But for sure it's possible to make analog models, digital models of analog circuitry in the FPGA, if you want to. Yeah.
Fair enough.
Yeah.
So do you have input from... So you said you had quality up front and everything like that, but another big concern I would think would be the actual process nodes and working with fabs and stuff like that, because you eventually have to imagine that the stuff will be made. Even at a startup, I'm sure the focus is on getting the hardware in there. And so did you already have an agreement in place with a foundry, or did you just knew that we're going to be on this process node and there's these constraints and there's 6 or 7 foundries that can do this stuff? How did that whole thing work?
Yeah, no, the foundry node is certainly very important, and we are working with TSMC in Taiwan.
Okay.
Which is you probably know it. I mean, it's basically the biggest.
That's the biggest.
Yeah, they're the big player.
That's the monster.
and certainly there are alternatives, but we had worked with the TSMC before, and it's a big advantage to both be able to take advantage of the relationship that you have, and they know you and you know them, and also, I mean, to give them credit, TSMC, they're the biggest for many reasons, but they're the biggest also because they're really good at what they do, and they are. I mean, you can trust them basically.
Right.
Yeah. Yeah, I mentioned last week's show about Intel, and I used to be in the semiconductor industry, and how the equipment vendors would talk about Intel. Well, the other ones they were talking about was TSMC. It's like, oh, those guys. I mean, they would thump on them, and they'd make sure that they were getting the best process equipment. They were leading the nodes basically. I mean, it really is Intel and TSMC that are leading that stuff. So
yeah,
that is a nice advantage.
How easy would it be to pick up and move from TSMC to someone else? If you had to, let's say TSMC couldn't actually deliver because they're producing 10 billion chips for Apple, and you really need parts. How easy and how fast could you move to another foundry if you had to?
Well, it's not trivial, at least.
Right.
It would depend on at least how compatible the processes were, and probably it would be similar to a new, say, chip design. Of course, saving some that you just don't want it to do the same as you've done before. Mm-hmm. But they probably have to re-simulate a lot on the analog in particular, and perhaps even do a complete redesign depending on the differences.
Ouch.
Yeah. So it's quite challenging. So you're kind of stuck. But let's say if you wanted to, and if we had to, I would just guess that it would take us like up to half a year probably to do it.
To move.
So it's like if there's a supply problem or something like that, it's like, no, we can't just, you kind of hitch your wagon to TSMC at that point, and you have to kind of work through it with them and stuff like that.
Typically, yeah. Of course, you could invest these kind of things up front, right? Having a dual supply, but I think almost no one does that anymore.
Oh,
right.
I mean, people used to do that for, say, analog chips, right? Before.
Yep.
And some even said that this was a must. But I think if you look at the digital chips today, or processors, I may be wrong, but I don't think anyone does it anymore.
Got it.
It's too costly, and it's too hard to actually get compatible processes. I mean, of course, inside TSMC, for instance, they do have different fabs that can manufacture the same stuff. Right.
Yes.
So if there's an earthquake or a fire one place, you may still be able to at least manufacture a percentage of what you had going the other factory.
So that's a scale thing, right?
Yeah. What is your strategy with actually when you manufacture these chips? Is it you manufacture probably just enough to satisfy your current demand and a little bit of stock, or do you go, right, well, we've got a run schedule, we're going to do 10 times more chips than what we have orders for? Do you keep a lot of stock, or what's the strategy?
I think I'm not sure how much of this is public or not.
Okay.
But I could give you a little bit of an answer.
Sure.
So lead time, as seen by our customers, is extremely important.
Of course. Yeah.
And
that can make or break a deal. Yeah.
Yes, and I mean, depending on the semiconductor cycle, right? In periods, big manufacturers have like half a year lead time, which is killing customers, right?
Yep.
I mean,
they
don't know what to
both
do.
Myself and Chris have been caught up in that before. So
yes.
Yep. Almost every designer has.
Yeah, and so basically lead time is one of the really important factors for us, right? If we have a really high lead time, then this will be an argument for not choosing Energy Micro. So we do focus on low lead time, and even the lead time is less than the manufacturing time in the silicon fab. Right. Which means that we are actually manufacturing upfront based on
sales projections,
forecasts, to some degree, of course. And then depending on, also of course we have different package options and so forth. So, I mean, after the wafer fab, we have to go through test and assembly, or perhaps also the wafer testing and assembly and final test, and so and it's quite complex, right? With the number of products that we actually have. And different variants on memory configurations and everything. So it's a bit of a challenge, but we have a big focus on lead time, which basically means that we have to be a little bit forward-leaning when it comes to manufacturing.
Sure. With the low, I mean, you differentiate yourself by having super low power 32-bit processors. Are they the lowest in the industry, or do you have competitors in that sort of low power ARM core market?
Yeah, so certainly we have. I mean, it would be stupid of me to say that we don't have competitors.
And who would they be? Who would be your main competitors? You think, probably.
Well, I think probably our main competitor, if I was to mention one, it would be ST.
Right.
Yeah.
Okay.
Gotcha.
I haven't looked at the ST ARM processors.
No, I mean, they have a lot of different versions, and some of them,
right.
Some of them are low power, and some of them are not. And then, but I think, of course, the Cortex itself is important. And I mean, say a lot of people, including ourselves, mention like microamps per megahertz or some benchmarks saying current consumption or energy consumption or something per frequency or whatever.
Yep.
But in a lot of cases, that's not where the battery's energy goes, right?
It'll be in sleep mode or something.
It'll be in sleep
power
mode,
down, idle, real-time clock running in the background, or
I mean, whether or not you have this, like for instance, we have a low baud rate serial port that can actually be active in a 1 microamp current consumption and move data via DMA, etc. While you're actually in this extreme low power mode. So how much battery do you save by that? Well, of course, it depends on the application, right?
Of course.
But if you actually have the use for this, then it could save you 1,000 times. I mean, or if you don't, then of course it's not going to save you anything.
Exactly.
But I think
I've seen you've got a chip. Sorry, you've got a chip there that actually. Well, one of your modes is that you can do direct memory transfer from an analog to digital converter straight to the memory without even powering up the ARM core.
Yeah.
Is that right? I mean, that's a complete data logger right there without actually running your processor.
We have a what could you we have something called LESense, which is low energy sense.
Yep.
Oh, it's not like a French version of sensing.
No, but actually that's where the name came from. It came like a joke, in what's that in Pulp Fiction? We have the Le Big Mac, right?
Oh yeah.
We have the Le Sense.
Royale with cheese.
Yes, but actually the name just kind of stuck. So,
nice. That's awesome.
And probably no
See,
one
that's the kind of mythology we like hearing about.
Yeah,
that's awesome.
So and actually it can do like sensor excitation and measurement and like do touch sensing with about a microamp per button, even with a good response time.
Wow.
That's awesome.
And that's all without using the processor,
It's all without using the processor, yeah. And
fantastic.
I think what we've seen is that, I mean, every time that we do something, of course we, as everyone else, also look at our competitors, right? Okay, so what did this competitor think of this time? Or what does our customers tell us that our competitors does, which is a, say, good idea? Of course, we also do that. But I think that a lot of times when we've seen that there's something that came up with ourselves, right? So that we actually made something that we didn't hear about before. We just thought this would be a great idea. That's when we really make a difference, and that's where we can really say make a big difference when it comes to the customer needs, right? And to really solve, perhaps even solve the issues that the customers didn't know that they had, or actually didn't know how to solve.
Yeah, it's like revolutionary versus evolutionary innovation, right?
Yeah,
that's like the buzzword bingo right there.
Yeah.
That's great. That's really cool. I mean,
I think these kind of peripherals and power modes, those are actually, I mean, really killer features. So certainly the Cortex M3 and what it can do, and I mean, high processing power versus low power consumption and ease of use and everything is great. But I think the main differentiator that makes our customers select Energy Micro is still I think this first point is just something they need, and then the additional point is the stuff that makes us be selected.
Right. I've got a question from Heinrich here. What is it like running a semiconductor company from Norway? Is it hard sourcing expertise, people? And did you ever consider moving to Silicon Valley where the action is, in quote marks?
Yeah.
You know?
Well, I think, first of all, actually, Norway has a fairly good semiconductor industry. I mean, fairly good meaning there's a reasonable amount of companies, meaning that there's a reasonable amount of experienced people and also education-wise. It's So I mean, we do have challenges hiring the right people, and we don't just have. Sometimes we're not able to hire. I mean, even though we need people, but in reality, right, we have. Of course, NG Micro, and we have the old, say, Chipcon team, which is also a good-sized team in Oslo. And in Trondheim, you have Nordic Semiconductor that you might know of.
Yeah,
and also the part of ARM that designs their graphics course is in Trondheim.
Oh, interesting.
And
right.
There's also a division of Omnivision, previously Photobit, located in Oslo, and of course not to forget the Atmo. So all the AVR controllers are designed in Trondheim.
Oh,
interesting. I didn't know that.
Also the AVR32 controllers, and I think even the manager for the whole microcontroller division of Atmo is in Trondheim, or at least he's from there. So actually the semiconductor industry in Norway has been growing a lot, and could I tell you my boss's favorite joke?
Of course.
Yes.
Thanks. So it's he typically tells this in customer visits. I mean, so Norway is of course, or not of course, but it is a fairly rich country, and the reason for this is because of the oil, right? We have had oil pumped up since the 70s, right, and it's produced a lot of money for us, and the second largest export part is fish.
Right.
And so, but actually, I mean, it's clear that the oil is going to go away, right? Because it's
peak oil
always
and all that sort of
search for
stuff,
more, right? But and then Norway is just going to export fish and chips.
Yes. That's a good
Brilliant.
one.
Yes, very good.
Like
I'll pay that one.
Yeah. So, but to answer the question, I think also, I mean, Norwegians, we do love our country and enjoy being in Norway, which is it's a fantastic country to live in, as long as you don't care about the weather, at least. So
yes, there's a song by one of my favorite groups called Of Montreal. They have a song called Oslo in the Summertime, and it's it's an interesting song.
Yeah, exactly. Yeah.
Oh,
yeah, it's not necessarily stable, at least.
Right.
But so I think Norway is a good place to be for a semiconductor company. I mean, the costs of having an engineer in Norway is actually lower than the costs of having an engineer in Silicon Valley.
Right.
So living costs,
sense, yeah.
So Norway is an expensive country, but we're a social democracy. So, I mean, people with low wages still earn more than in Silicon Valley, of course. I mean, working at McDonald's isn't so much lower than being an engineer at NG Micro.
Really?
I mean, there's certainly a difference, but
right. Yeah, of course.
Yeah.
Right.
Interesting.
Wow. We've got a question from Eric. Can you tell us more about your radio system on chip?
Yeah, I was wondering
stuff?
about this too.
Yeah, because you not only do you do two products effectively. You do the Gecko microcontrollers and you do these radio devices.
Yeah, that's true. So it's we call this EFR, so it's called Energy Friendly Radio.
Yep.
And we have a family coming, or actually, it's multiple families of radios coming this year.
Okay, so they're not actually out yet.
They're
in
not actually,
beta silicon.
They're not in the market yet.
Right.
But it's quite actually a flexible family. I mean, both when it comes to support for different frequency bands. I mean, both for 2.4 gigahertz and a lot of sub gigahertz frequency bands.
Yep.
And also a lot of different radio communication protocols like 802.15.4 I mean the IEEE standard, and Bluetooth LE and wireless MBUS in the sub-gigahertz range, and it's a lot of different standards. So basically what we did was to try to leverage on the experience that we had from both from ChipCon and from other companies trying to avoid that you have to make a new radio every time there's a new standard coming.
Right.
Trying to make it flexible enough from the first generation that you can still make it. I mean, there's never going to be something called forward compatible. I mean, in real life, but at least we try.
Yeah.
Try.
So how do these compare in terms of energy consumption to, say, Bluetooth LE? Is it in that league, or is it down compatible to ANT? The ANT, is it super low power like that, or?
It's going to be, it is really super low power, yeah. So we want to really benchmark against the best, and I don't think there's any point coming out to the market with something which is just a little bit better than what's already out there.
Sure.
So certainly we will be making a major step down in energy consumption.
So who would be your major? Who would you be targeting there? Would you be targeting ANT? Because I think they're probably the lowest on the lowest power RF at the moment on the market, are they? Or
well, I think ANT has a good traction in certain markets, right? For like your heart rate monitors,
heart rate monitors, and your watches and things like that.
Yeah, typically. I think there's tons of protocols for various both applications and say user scenarios but I mean ANT's definitely one of the good standards when it comes to providing a low power solution. I mean a real life low power solution.
Yep.
I think Bluetooth LE. I think whether or not Bluetooth LE is lower power than ANT or the other way around.
I don't think it is. I don't think it's even close.
I think it's more about the silicon implementation and on the configuration of everything, because even Bluetooth LE isn't just one thing. It's a configurable standard where you can set this hook, or you can, depending on, for instance, like latency. Like your heart rate monitor, it doesn't need to. You want it real life, but not. I mean,
not instant.
Yeah,
right?
you only need to transmit a couple of times a second or something,
Yeah, or perhaps even slower. So I don't think there's a single answer to this. I think that's probably more of what people will believe than what is actually real life. And of course, even Bluetooth LE is still quite early days, right? There are very few products on the market, and I think there's going to be a big change also. I mean, also when of course we come onto the market with our solutions for this.
So do you see? So first off, it's definitely not core based, because you're not buying these cores then, right? I mean, you're actually doing the silicon design.
Yes.
Okay. So I mean, do you see the same kind of thing happening that happened with ARM cores and other? I mean, because before, if some of our listeners don't know, I mean, there were many cores and a lot of people were rolling their own, but now everyone's kind of coalescing around ARM and these bigger solutions. Do you think the same kind of thing will happen with RF solutions and more standardized silicon eventually?
I don't think it's going to happen with standardized silicon when it comes to RF. No, I don't think so.
Okay.
But I do think that RF communication standards are going to. I mean, there are very many out there, and I think that not all of them will be. Around for forever and ever. I think. I don't know which ones are going to be really successful and which ones are going to die slowly. But for sure, I think having standard-based solutions is going to be key to be successful in this market in RF communication. Yeah.
We've got a question from George Hahn, and he asked, what influenced your decision to release so much software as open source? I mean, how much of your software is open source, and have you benefited, or do you expect big benefits from doing that?
One of our 4 company core values is simplicity. And actually, we're probably the only company in the world that has a VP of simplicity.
Right.
I did see that on your
Wow.
on your site. I was wondering about that. I was wondering if that was just a typo or what that was.
So is his job really simple? Does he actually sit there and go, I don't have to do much because I'm the vice president of simplicity?
But his task is to make it simple for our users and the customers.
Got it.
So we're not trying to make it easy for ourselves necessarily.
Right.
And so basically, releasing our driver libraries, etc., as open source is part of just making it simple, right? Mm-hmm. I think it's not that uncommon either, but
no, it's not.
But I think it's just something you should do just to make it simple. And also we've recently changed the licensing scheme of this to just make it more simple and less, say, restrictive for our users. And perhaps we even do more over time.
Because Eric Smith had a question about this. It's a rather complex multi-part question, but he talked about GPL and how that can be an issue. GPL license can be a problem for some customers and things like that.
Yeah, and I think he asked whether or not it would be possible with a dual license, right?
Yes, that's right.
So yeah, that's actually something we. I forwarded that question to our VP of Simplicity, and they said, "Yeah, that's a good point, and we should probably take a discussion on it." But it's something we should definitely consider to do. Without, I can't promise that we'll do it right here and now, but we should discuss it. But in general, we want to just make it simple for our customers to go with our solutions.
Well, because
of course we won't be. Making our money based on the software, right? The software is,
of course,
only indirectly, of course, since the software is key to people actually selecting our parts.
That's correct.
Right. Making it easy to pull into your ecosystem is very important.
Because I've seen other companies get called out with this microchip, and I think Atmel as well, but microchip specifically, they claim that all this stuff's open source and everything, but if you read the licenses like the USB library or something, or the Ethernet library might not be, because it's based on something else that's actually proprietary, and so you develop your project around all their nice libraries for USB and Ethernet and everything else, and then you find, oops, I can't use the Ethernet because it's actually proprietary. Oops, that's,
that door shut. Yep.
Yeah, that can come and bite you as a designer later on. So
sure.
That's
sure.
And that's a really interesting focus. The whole simplicity thing. I mean, I think a lot of companies talk about that, but I don't think it's in there. None of them have a VP about that, so that's pretty cool.
Right.
Yeah. What about so from the software side, some of the people on our comment section asking questions were mentioning like communities and getting help with software and stuff like that. Obviously, a small company can't just directly answer questions, but I mean, are there resources out there? So if our users wanted to try out a chip and they wanted to, talk to others about getting up and running, I mean, is there a resource for that kind of thing, or even just a starting point on your site?
Yeah, I mean, we do have a website on support.ngmicro.com where you can actually just submit your questions and you'll get an answer. But and we are going to set up a forum as well, but I'm not sure about what the timing of this will be. But we certainly have discussed this internally as well. And again, it's part of making it easier. Right? So I think it's a good point and. Something we should definitely be doing.
Okay, so maybe an enterprising engineer or hobbyist out there could start up an easy site for now, and then it'll get pulled in later.
Actually, even there are some localized support forums, and but typically then, like in China or in Germany, there's some pages that are set up for EFM support, but probably not worldwide.
Okay.
Got it. I've got a question on the ARM core. I don't expect you to answer directly or know the figures, but how much of the final chip cost roughly would be the license fee for the ARM core? Is it a big percentage, or is it a small percentage compared to actually manufacturing the chip plus profit and everything else?
Yeah, it is, of course.
I'm sure it's very proprietary how much
license fee you... And it's very confidential, so I can't really answer.
Right.
Yeah, I can't really answer.
I do know that on ARM's site they talk about. I've seen presentations before because I was looking at investing in ARM at one point, but I have seen stuff, and people can go look at that. Maybe that's a better place for people to go look at it.
Probably.
But it's pretty low. I mean, I think in general it's a lot lower. I was very shocked. It was it was fractions of pennies for chips, at least when I saw it. So
okay, interesting.
I'm sure there's a big NRE cost and everything else, but it is an interesting model. I mean, what's it like working with them? I mean, is it when you guys were starting up? Did you guys get like a catalog, and were you like,
no,
we'll take that one?
Actually, it was kind of hard. It was kind of hard to really get in touch with them, even, right? Because
really,
we were no one, and who do you call?
Right,
exactly. Ghostbusters.
Because
who do you call?
ARM wasn't, at least at the time, set up to like certain. I mean, to cover a broad market, right? They have relatively limited amount of both customers and potential customers.
Right.
So it's not like they have a lot of contact points. But we were able to basically get in touch with the right people. I think we had to go through some back doors to find out who we're supposed to be talking to.
Yeah, and that's got to be a tough proposition too. I mean, you approach a company being like, we'd like to buy all of your source code, please. That's basically what a core is, right? It's like source code and
it is source
pulling
code,
it in.
Yeah.
But I mean, ARM has been fantastic to us and really supported us. And so we've had a great relationship with them. So I mean, after we got the right person in contact there, and they came over for a meeting to Oslo, like a couple of weeks later, and since then we've been working quite closely with them.
Mm-hmm.
So they've been great to us.
So what does the code come in? Is it VHDL, Verilog?
It's Verilog. It's Verilog.
Right. Okay. Yeah. And have you modified that, or do you just don't touch the ARM core? Did you find that you needed to modify it for some reason, or?
We have had reasons where we have had wanted to, from a technical perspective, to modify things.
Got it.
I mean, typically then in some very low details or like to allow some clock gating or something, but we're not allowed to.
Oh, right. You're not allowed to, or it's just too dangerous and silly to do that.
Not allowed.
You're not allowed to. Okay.
Not allowed to.
How would they know? Come on. It's not like you're on a radio show talking about it.
And how do you actually design these chips? What EDA tools do you actually use?
So we're using Cadence tools,
right?
So I mean, they basically have a tool for everything, right?
Of course, yep. At very high prices.
At a quite high price, yeah. But actually, they've also been. I mean, I have to say, quite good to us, and they've also been. They also have like special programs to support startups, and they understand that you can't pay. Yeah. And they have some, say, models where you can, But anyway,
sort of you can use now and pay later, maybe, or
at least payment terms is certainly one thing it's possible to talk to them about.
If you're a low-cost startup.
Yeah. So we're using Cadence tools all over. But of course, there's a lot of scripting involved, and a lot of stuff that we have made around this ourselves as well.
Got it.
What about future stuff? I mean, we had a question on here about, what did the person ask? Jean-Luc asked about, do you plan to use the new ARM Cortex M0 Plus core in your next generation MCUs? And just kind of, from me, would be, what is the future beyond radios and everything else? I mean, do you guys have a roadmap that you're allowed to talk about, or is there, what's next?
Yeah, so to answer the specific question, we're going to use the M0 Plus in our Serial family. I mean, this is the latest, say, upgrade of the M0 from ARM. Beyond this, of course, we have a lot of products coming on the radio side, and we have a lot. I mean, it's fairly obvious that we're going to be expanding both the number of microcontroller parts and radio parts in the years to come. Of course, with variations on peripherals and everything. Beyond this, actually, we had a very interesting internal process going on last spring, I think it was, where the whole company was encouraged to come up with these kind of ideas. What should be next?
Excellent.
we had a lot of, say, crazy ideas and a lot of, say, small ideas and incremental features. And I mean, it was really, really interesting to see all the things people were thinking about. I mean, from, say, energy harvesting to, battery technology to... But I think it's we do not have a public roadmap going beyond microcontrollers and radios, and it's probably at least going to take a little while. But I would say it's quite likely there's more stuff coming from NG Micro in the future as well.
Excellent.
I wouldn't expect any less. I mean, only all these processors and all these radios in a couple of years. Geez, I mean.
Well, that raises the question I wanted to ask. Once you've designed your first device, like it took you like 18 months, 2 years to get your first one out, how easy is it to then produce variations of that, you know, the tiny gecko and other variations of the gecko family?
Yeah, so like the tiny gecko, there was a certain amount of new functionality, but of course the rest is a variation, like you say. And the whole design flow that we made from the beginning was targeted at making it easy to make these variations. So we have like a chip description format, kind of similar to XML, where we can describe a chip, like how many UARTs, memory maps,
run a script, and
in theory, out it pops, yes.
Right. Oh, excellent.
But of course, there's more to it, right?
Of course.
And not only out pops the RTL code, but the documentation and everything.
Fantastic. Because a lot of, I mean, if you look at Microchip or somebody like that, they've got like how many thousands of different devices do they have? I mean, it almost borders on crazy. Are you planning on having lots of variations, or do you think it's better just to have, you know, just a couple and that's it? And, you know, even if it's not tailored to your individual application, it's better to have just a few for support, I think, easier support.
Yeah, I think it's necessary to have a relatively large amount of variants. Yeah, I think it's necessary. I mean, both because sometimes we have this discussion internally, right? Should we or should we not make this kind of variant, right?
Yep.
And sometimes we say that, okay, no, let's not make it because we have this other variant. It has more, but so it's still going to satisfy the customers. And then, like a couple of weeks later, there's a email from the sales guy. He's been to this and this customer visit, right? And they asked, "Why did you not make this part?"
Right.
Of course.
I think it's quite typically human as well, right? We don't want to pay for something we don't
use. Yeah, exactly.
Use because we feel cheated, right? Or whatever.
But how hard is it to support, you know, hundreds of devices or whatever? I can imagine it'd be a nightmare.
It is quite hard, actually, to be honest. Yeah, but or at least it's not trivial. But as long as we build the right systems around it, it's definitely something we were able to do without sacrificing on quality or.
Got it.
Yeah,
because that's as a designer, that's often a scary thing. Oh, you know, Atmel come out with a new variant, or Microchip come out with a new variant, or Energy Micro come out with a new variant, and it hasn't, you know, it doesn't have trust, you know, because you haven't used it before. Are there silicon bugs in it? You know, I'm very some of the major ones are filled with silicon bugs. You know, it's not unusual for whole things in the chip not to work.
Yeah, the errata sheet is a very scary thing, right?
It's crazy.
Yeah. So of course that's a challenge, but something we just have to deal with and make sure that if we have bugs, that at least they're described and being fixed.
Got it.
Yeah.
Yep.
So another thing that always scares me, and actually something you guys address right on your website, is longevity, especially with like a startup.
Yes.
You don't know. I don't know if you guys are going to be around tomorrow, right? I mean, no offense. I mean, your history is only so long, right?
Yeah.
But that's interesting though that you put guarantees on here, which is a big thing. We talked to Tom Laments from the auto industry, and he was talking about 10-year lifetimes.
Yeah.
And it's an interesting thing. Can you tell us a little more about the longevity stuff?
Yeah, so I mean, the reason why we made this and the reason why we put it on the webpage is just to put this question to rest, because it's typically something that comes from at least industrial style customers.
Yep.
Right?
You bet. I've asked it myself. And it's often next to impossible to get them to give it to you in writing. Because I've worked in military industries and other industries that we need this sort of stuff in writing. And it's like extracting teeth from them. It's next to impossible. But you guys have put it right out there on your webpage. We'll support these chips for 10 years.
Yeah.
It's great.
Simplicity.
I'm printing this out right now. It's
well,
just this is a legally binding document now. So legally binding
indexed by
HTML.
Google.
Yeah, that's interesting. It's good though. It's a good sign. I mean, it's long term thinking, all that kind of stuff is very important for silicon. Because it is such a big investment, not just from your side, but also from a design side. If I'm deciding, well, I'm going to put an NG Micro into my design, I don't know how long my product's going to last, but I can be damn sure that if I'm making it in 10 years, I'm going to be wanting to use the same chip. That's a very important thing to me.
And like if you move into industrial or medical applications, you may have to run through a whole new cycle of getting like governmental approval or FDA approval, or you can't just replace a part without going through this cycle again.
I know.
So
it's very expensive and it takes a long time.
Yeah.
Well, speaking of simplicity, I was thinking about how I had found out about you guys, and it was actually through DigiKey and just the whole. A lot of people find new stuff that right. I mean, you're looking for maybe low cost or low power. You're doing like a parametric search, and you're like, who the heck are these guys, right? No offense.
No.
and so I'm just wondering though, like, is that how you guys find a lot of new business? Is like how did that whole thing work with getting set up with those guys too? Because I mean, at least for the hobbyist side of things, who a lot of our listeners are even smaller producers of hardware, like in a professional capacity, that is the first step, is going straight to distribution, seeing what's available today and seeing, what kind of parts I can get.
Yeah. So actually, I mean, we've been working almost from day one with distribution and making a good setup there. I mean, worldwide. So actually, we started signing up distributors. I think also back in 2007, before we had any products.
Nice.
Also to be able to get the relations with their customers, to make sure that we address the right customer needs, right, and make sure that we make the products that people want. And then going to like DigiKey or Mouser has been important for us as well, to make it easy for people to get samples or to just get a few parts without a big hassle. It's very important for us to I think both to be able to support the kind of hobbyists or students or people who just want to play with stuff and have fun, and of course realistically, we're going to make the majority of our money on companies that are medium to large, but still a fair amount of our revenue will likely come from the smaller customers, because there are more of them, and of course we're very happy to get into small designs as well as big designs. And the more people, you probably know more about this than I do, but the way Microchip was able to grow from basically nothing to a lot was basically to be able to spread the technology widely.
It was the hobbyist market. They were the first low cost, easy to get micro, and that's what cemented their position. Yeah,
and Motorola at the time, they didn't care.
No, that's right.
And then they lost.
Yeah, that's right. So, big time.
Yeah. So of course we're inspired by their thinking and the way they've been able to build their business. So we want to be able to support this in a good way, and then, like you say, DigiKey and their likes like Mouser or others are extremely important.
Oh, and from a designer point of view, as Chris said, that's the first thing we do. We go do our parametric search and we use the chips that we can actually buy on DigiKey and Mouser.
Yeah,
if we can't buy them from them, I was walking
down the aisle of the cubes at my office the other day, and I was just kind of like peeking in, and I saw probably 5 screens open to just distributor websites. It was easy, you know, like you just seeing what's out there because that is the first step. And I've told that to distributors before, you know, like that is the first step, and those guys want to be the first step, you know, like.
and that's not just for small players, small designers, small companies. That's for, I've worked in big companies where that's the case too. You look for what's available because you need a prototype next week, and you know, and if you can't get the part, you're screwed.
Yeah.
Oh, we've got a question from Seb. I won't try and pronounce his last name. He's says that a lot of the features in your Simplicity software environment are really nice. And he asked, where did the software and the features in that, where did they come from? Did you plan that from the very start that you'd have these easy-to-use software tools, or did that come later when you thought, oh, this would be cool if we had...
I think a lot of it came later.
Right.
I remember, I mean, so we have a tool called the Energy Aware Profiler, which has been great to us. I mean, having this tool, and it's basically where you can see the energy consumption or current consumption live.
Yeah, per individual subroutine. I've done a video on this, and it's quite excellent.
And actually, I remember that we talked about this internally, that this would actually be possible. But we thought that I mean we'll just leave this stuff up to the kind of IDE suppliers, and we don't want to step on their toes and so forth. But I think the truth is that the way I remember it, at least, is that one of the guys basically just sat down over the weekend and just made it still. And then
awesome. Yes. That is great.
That is how the best stuff comes out.
Yeah. And then that's pretty cool. And then we were able to demo this before the IR guys, or IR. They also have a plugin similar to this. I mean, with the basic same functionality. Mm-hmm. But we made the prototype initially, and just to have basically made it to a product later on. So some of this, I guess, has been a little bit planned, a little bit better planned than this one. But apart from this, I think it's a combination of planning and just doing stuff. Actually, we have another good thing in the company as well. I guess inspired by companies such as Google or others, where a little bit different from different departments in the company. But like once a month or something, you get a day to just do whatever you want.
Great.
Oh, yeah, like a blue sky kind of day, right?
Yep.
I mean, that's...
Yeah. We call it the Hack-a-Gecko Day.
Hack-a-Gecko. Where did the gecko name come? Where did you choose how did you choose the gecko as your symbol?
Yeah, that's a good question. So actually, it was just before the launch in 2009 where we're going to go public with our products.
Just before the launch? It was a last-minute thing?
Oh, man, I bet marketing
loved that. Right? Yeah.
And our CEO was watching a BBC documentary late Sunday evening with Sir David Attenborough.
Nice.
And
brilliant.
He was talking about how reptiles and amphibians, I mean, sometimes you can think of them as dumb and slow, but in reality, they're extremely fast and they can actually have energy consumption, which is 10% of a mammal of a similar size.
They are very energy efficient. It's very true.
They are.
Yeah.
So that's how this came about.
At the last minute.
That's great.
Brilliant.
That's great.
We're going to Fab. We need a name for our chip.
Yeah.
Everyone looks around. You know?
Yeah.
Oh, that's great. And we've got another question here from Kevin that relates to the software that we're talking about before. He says, how are you able to measure the power use per function call? Is it an actual measurement, or is it just a calculated estimation?
Well, it is an actual estimate, but of course it's an estimate.
Right.
But okay, what we do is two things. Or we start off by having this live current consumption estimate. No, sorry, not estimate, but current consumption measurement.
Right.
And additionally, there's some features in the Cortex M3 core, which allows us to output the program counter either, I mean, it depends on the different which chip family you're talking about, but either on like a serial interface or also in some cases on a semi-parallel interface with more trace functionality. But anyway, on this output, we get the program counter, and on the outside we have the linker file, or not the linker file, but the mapping file, which tells us. So if we have a certain program counter value, which function is this actually inside?
Got it.
Yeah. But for sure, there's some weaknesses to this. Like it's possible sometimes that you have a function which is called, but you don't get the program counter sample still of this function. So it will
it can be slightly off. Yeah.
It will tell you a fair description of the real life, but it will not. It will never be able to be, say, perfect.
It won't ever be cycle by cycle kind of.
No, and even you couldn't measure like the. I mean, just imagine even that the execution inside the cortex is pipelined, right?
Yeah, I know, it's crazy. Yeah,
so you can't really extract cycle accurate information, but you get a good trend, and typically you catch a lot of these kind of busy waiting loops where you see that you're actually busy waiting for a long time where you thought there was nothing, or
Got it. Are there any other competitors out there that have a similar sort of functionality in their own tools?
Well, I'm not aware of any.
Yeah, I'm not either. I think it's fairly unique. So that's almost a killer feature, and it's and I think it's so obvious. I mean, you have these low energy power micros, and you expect to have this capability to measure this sort of stuff almost.
Yeah.
So,
I know there's some third-party tools that allow you to do a lot of code, analysis and see where you're sticking around in different routines and stuff. But you probably have to extrapolate that to actual power or whatever you're putting it on.
Well, I've done that thing before. Yeah, there's lots of manual processes. You have to estimate how much time you spend in that routine and then measure the average consumption and then divide it by that. And it's, it's it's just not very nice.
Right.
Yeah.
All right. Well, I think we may have overdone our amp hour, but it was definitely worth it, I think.
It was definitely worth it. Have we got any last minute questions we haven't answered? I think we got through a good lot of them.
About 30, yeah. So.
30. Oh, wow. Okay. That's wow. Yeah. That always amazes me.
It was very good.
Yes, Oyvind, thank you so much for being on the show.
Thank you very much, Oyvind.
It was awesome. You can find Energy Micro at energymicro.com. I'm not sure if you guys are on Twitter or not, but
yes, they are.
They are.
At Energy Micro, yes.
All right, so you can treat your questions there. I'm sure you'll have people listening to this show hearing about your internal stuff and wanting to come work there too. So
actually, also from our marketing department, they told me they're going to give away some kits to some of the people who have asked questions.
Ask questions. There was 10 Tiny Gecko kits they're giving away.
Yeah,
great.
Yes,
great. So we'll get in touch with those people. That's awesome.
That's great because development kits are everyone loves getting a development kit and that's great. What's your philosophy on the development kits? Do you keep them as low cost as possible, or do you want to actually make a bit of money on them?
We're not making money. I think perhaps we're losing a little bit money, but we're not making money on the kits.
Make it up on the back end, yeah.
Yes.
But you certainly don't want to give them away, do you? Because people like Texas Instruments, like $4.30 for their, for their little development kit delivered. Crazy. They're just you may as well give it away for free. It's just
you're getting there. Huh? Yeah.
So you don't want to go in that direction?
Well, I mean, sometimes, of course, on a case-by-case basis, we may give away, or even our distributors may give away. We sell it to distributors, and they give it away. So, of course, there's a lot of different variants, and we sometimes we have promotional activities, right? But you're. I think the only thing we don't want is to give it away, and then it just ends up in some drawer, right?
Of course. Yep, that's there.
I've got that drawer. Yep.
And do you actually sell any software or any development software, or is all the software free?
No, all our software is free, yeah.
Excellent.
Yes, it is.
Because I was talking to the Microchip CEO a year or two back, and he said their philosophy is that they don't want to give away their software for, some of it they give away for free, but the high-end stuff, they don't want to give it away, because then if they give it away, because it's such a huge corporation, the bean counters within the company, the finance people, will see that division's not making money, and they'll want to shut it down.
Yes.
and the CEO, even though he's the CEO, won't have the power to stop him shutting down that whole division because it's not profitable. It's like crazy,
Which is why it's important to have a technical CEO to even recognize that. So that's good.
Yeah. So what are the plans for Energy Micro? Do you plan on growing into a big company, or staying lean and small and fast and agile?
We plan on staying an independent, say, small to medium-sized company.
Yep.
Basically growing our business worldwide. So probably also, go in the stock exchange in some years. Mm-hmm. That's the plan.
Oh, okay. So you will list on the local Norway?
Probably, yeah.
Or
probably.
the American?
I'm guessing Norway, but I guess this is something that I'm just the CTO, right?
Right, exactly. You don't care about money, right? As long as you're making cool stuff and
as
hacking
long as it's
things.
fun,
That's right.
That's great.
Oh, I love it.
All right. Well, thank you again, Øyvind. It was awesome talking to you.
It was great talking to you.
Fantastic insight into the company. I hope it goes well for you.
Yes. And thanks again to Øyvind for being on the show. It was really great.
It was.
We'll see you next week.
Bye.
Cheers.
All right.
Well,
so we'll see everyone next week, and you can catch us on. You normally do the outro, Chris.
I do. I already did it, Dave.
Oh, right. Oh, and then I jumped in with more questions. There you go.